Chapter 16, PERT and CPM Models for Project Management. This week we will be talking about the first part of Chapter 16, which is the critical path method. Next week we will work on the PERT method for project management. Regardless of which type of methodology we use in our project management, each project will have certain phases that every project goes through. Phase 1 is the project planning, where we set our goals, define the project, and organize the team. And you can see some of the questions that are asked here in this phase of project management. What is the goal or the objective of the project? What type of activities or tasks have to be completed? Are these tasks or activities linked in any certain way? Meaning, are there predecessors to the relationship and perhaps successors, meaning what has to come after a certain activity? How much time is required for each activity, and what resources are required for each one of those activities? The second phase in project management is the project scheduling, and this is where we get detailed specific time schedules for each activity and the people and resources and, of course, the money that needs to be assigned to each one of these activities. We will determine when the project will be completed based upon all of our schedules. What is the start time of the project and when will it end? What are the critical activities in the project? Meaning, if this activity gets delayed, it will delay the entire project. What are the non-critical activities? Meaning that, and we'll talk about this as we get a little further on, there's some slack, that meaning it can run a little late and it will not affect the entire project. And then we'll talk about accounting for uncertainty in the project. The final phase that we talk about in project management is controlling the project, meaning that, okay, now the project has been launched, we have all of our schedules, and now we need to monitor those schedules and the resources and the budgets. And always check in to see our activities running at the amount of time we said they would on the schedule. Are they behind schedule? Are they ahead of schedule? How are we doing to budget? Are we meeting our project budget, or do we have overruns? Very rarely do we have less than budget. And are the resources that we identified in our schedule in phase 2, are they going to be available to us when we need them per the project schedule? And then lastly, is there, now that the project's underway, is there a different way that's been identified that would allow us to complete the project sooner and perhaps even under a budget? For phase 1, the project planning, for what we're going to do in an academic environment, all of this information is going to be provided to us. We're going to break down the activities into smaller units of completion. So we're not just going to say, build the house. We're going to break it down into, okay, what does that entail? What are the activities that have to be done in order to build a house? Each activity should be clearly defined with a start point and an end point. Each activity should be distinguishable from every other activity, and you can think about it that each activity can be a project in itself, meaning that perhaps in building our house, one of the activities is to paint the interior. Okay, what does that entail? Well, we have to make sure that we have the paint purchased, that's available, and all of the supplies are available, and painting each room. So we can break down each activity into smaller intervals or sub-activities within a larger activity. We would identify what has to be done. Well, obviously we have to have drywall up before we could paint a house, so that would be a predecessor. And then we're going to determine how long does it take us to paint the house, and how many painters do I need, and what supplies do I need, how much paint do I need based upon the square footage, etc. We're going to spend, at least right now going through the critical path method, we're going to spend time talking about, okay, how do I set up my schedule? The critical path method is one way to do it, and then we're going to talk next week about the PERT method, the Program Evaluation and Review Technique. The difference between the two different types of project scheduling is in the PERT method, each activity that we have identified in our project schedule has 3 time estimates that are combined essentially to get us an average expected time to complete that activity. The PERT method is considered the probabilistic technique. It allows us to find the probability that the entire project will be completed by a specific due date. And we'll go through some very specific examples when we talk about the PERT methodology next week. Like I said, this week we're going to talk about the critical path, or the CPM method, to project scheduling. And what that does is it estimates the time of completion for each activity using a single time estimate. It's considered deterministic because we decide, okay, we believe that this activity, based upon previous experience with that activity, will take us X number of days or X number of weeks under typical conditions. So we're not really giving it a, hey, best case, everything goes great, it should take us this long, and worst case, if everything goes wrong, it would take us this long. We just look at our historical time for that activity. We say it should take us a certain period of time or duration to complete this activity. We're going to learn the critical path method by looking at this project that is being done by the Reliable Construction Company. And you can see there's a lot of questions here, and we'll actually get to all of these, but not necessarily all of them through the CPM methodology. But essentially, Reliable Construction has just made the winning bid for construction of a new plant for a major manufacturer. And there's some penalties involved if they don't meet their schedule, and there's also some bonuses involved if they're able to complete prior to the projected completion date. So what Reliable Construction Company employees have done is they have identified all of the activities that need to be performed in order to build this manufacturing plant. So you can see that the activities go from A through N, and they each have a description. They have to excavate, lay the foundation, put up the wall. You can imagine that within each one of these major activities, there's sub-activities underneath them, because lay the foundation isn't as simple as lay the foundation. So they'll have a very, very detailed project schedule under each one of these activities. We're just going to keep ours at the high level with these major activities. They have identified the immediate predecessors, meaning what has to happen before I can do an activity. So excavate is the start of our project, so there's no predecessor, and it's estimated that excavation will take us 2 weeks. After excavation is done, they can move on to activity B, which is lay the foundation. So the predecessor to activity B is the excavation, activity A. Activity B, lay the foundation, is estimated to take 4 weeks. Activity C, put up the rough wall, cannot be done until both A and B are completed. Now, you'll see that to put up the rough wall, we have to have both excavated and laid the foundation, but we only list the immediate predecessor to the current activity because we can't get to B if we haven't done A. So you'll notice that in some cases, even though a couple of things have to happen before we can do the current activity, we will just list the immediate predecessor to the current activity. Then we have to put up the roof, install the exterior plumbing, interior plumbing, exterior siding, and now here's one where we have two immediate predecessors. Do the exterior painting. So before we can do the exterior painting, we have to have installed the exterior plumbing, activity E, and put up the exterior siding. So this activity, activity H, has two immediate predecessors that have to have finished before we can begin activity H. And if you look through it, just shows you how each one of these activities is reliant upon a previous or predecessor before it can begin its stage. And then we have the estimated duration for each one of the activities. I'm going to jump to this slide down right here. This is a picture of what we just talked through. So we have activity A, B, and C, and then based upon the predecessors, we're showing a flow chart of how this schedule will work. This is what we're going to build in Excel, and we'll work through that in a few minutes. But let's go back up here. When we talk about drawing, we're going to draw that project network in Excel. And the project network consists of nodes and arcs. There's two ways that you can build the project network. One way is called the activity on the arc, where each activity, so A, B, C through N, is represented by an arc or an arrow. And then the node is used to show a separation between the activities from its predecessors. We're not going to use that way. We're going to use a style of building project networks called activity on the node, AON. Each activity, A, B, C, etc., is represented by a node, and then the arcs or arrows are used to show the relationship from the predecessor to the successor. The advantages of using the AON, or activity on the node, is it's a lot easier to construct and it's a whole lot easier to understand. And then it's also easier to use when we're revising for any changes, which happens quite often in project management. So again, here is our activity list, and the activities would be our nodes, and then the predecessors would be our arrows, essentially our flow chart. So again, back to that graphic where we've built our project network, the nodes are our activities, and the arrows are our arcs, showing what is the relationship, what has to happen before I can do another step in that activity. So what I'd like to do is have you go over to Excel at this point, and again, if you have not opened up the Excel file that goes with this chapter, please jump over to Canvas and open that up. I would recommend pausing the video for a minute and going over to Canvas and opening up the Chapter 16 Part 1 Student Worksheet. And this will be what we're working on to build our project network using the critical path method. Okay, so I have in here, I just pasted the construction activities that came off of the PowerPoint we were just looking at, just so we don't have to bounce back and forth. It'll just make it easier for us. And then I've also put in here a little box that we're going to use to work through building our project network. We are going to talk about what these mean, EST, EFT, LST, LFT. But for now, we're going to put in our activity, so A, excavate, and the duration, and build out our project network using these diagrams. Now, I put them here along with the arrows, so these would be our nodes, and these would be our arcs. just because I don't want you to get frustrated if you're not sure how to build these keys. But essentially all I did was I highlighted 3 boxes, or excuse me, 3 columns and 2 rows, and then I came up here to the borders and I said put all borders around it, and then I went in and I just said, okay, this is going to be EST, LST, EFT, oops, and LFT. And again, we're going to talk about what do those mean in just a few minutes. And then I put in the activity name and the duration. And I just made my column wide enough to be able to see it. And then personal preference, I just highlighted that color to be blue just so I could see that's where my activity name and duration go in. For the arrow, if you're not sure how to get an arrow into Excel, what you would do is you're going to come up to Insert, and we're going to go to Shapes. And then I'm just going to use, you can see I have recently used it, or you can come down here to Lines, Line with Arrow. Just go in and tell it to insert it there, and it puts one in, and you can just play with it and make it the length you want. So again, they're here already for you. But if you wanted to build your own and know how to do it, that's how you would do it. I'm just going to use this as my keys for, and I'm going to cut and paste, or excuse me, copy and paste all of these as I need them. Okay, so our goal right now is to build our project network, listing all of these activities and how it flows based upon the immediate predecessors. Okay, so the first thing we want to do is have a dummy node, which is our start. So I'm going to come over here and I'm just going to copy my node and put it over here, and this is going to be my start. Okay, it has no duration. Okay, so this is my dummy node. It's just saying, okay, this is the start of my project. If you think about it back here on our PowerPoint, get to the slide that shows it, right here. That's our dummy node there. So I'm doing the same thing in Excel. Okay, then it says from there, I have to excavate. So from my start, my first activity is to excavate. So again, oops, I'm going to grab my arrow first. I'm going to say, okay, from my start, I'm going to then excavate. So what I'm doing, guys, to do quick keystrokes, you can see I did that fairly quickly. I came over here, I clicked on my arrow, and then you can do up here, you know, honestly, I use the hotkey so much I have to stop and think about how to even copy that. But I have it highlighted. I'm going to do Control C for copy, and then I just come up where I want to put it, and then I do a Control V for paste. So that gets, I'm just copying my arrows up there. So I'm going to start, and my first activity is to excavate. So I'm going to grab one of my node boxes, and I'm going to put it over here, and I'm going to say, okay, this is activity A, and that's to excavate. And activity A has no predecessors, so it's coming right from my start, and its duration is 2 weeks. So I'm going to put a 2 in there. Again, don't worry about these numbers right now. We'll get back to them. It then says that after I complete activity A, I can complete activity B, which is lay the foundation. So again, I'm going to grab an arrow, Control C and Control V to show that, okay, coming off activity A will be activity B. So I'm going to grab my nodes again, come over here. This is activity B, which is foundation. And according to my project schedule, activity B takes 4 weeks. Okay, stop the video if you need to. Go back and make sure you see how I'm just really building my project schedule at this point, my project network. Okay, get comfortable with how you're just kind of copying and pasting the nodes and the arcs into your worksheet. Okay, so now I'm on to activity C. It says activity C, put up the rough wall, can occur after activity B. So that's immediate predecessor is B. So again, I'm going to come over here, grab one of my arcs, Control C, put it after activity B, and Control V. And I'm just going to save myself some time. I'm just going to copy this and put it here. And instead, I'm going to call this activity C, which is rough wall. And the duration for activity C is 10 weeks. So my duration will be 10. Okay, now we're going to start to have a little bit of variation because a couple of things can happen after activity C. We can put up the roof and we can install the exterior plumbing. So activity C is the immediate predecessor to D and E. So what I'm going to do is come over here. I'm going to grab one of my arcs, Control C, Control V, and I'm going to do Control V twice because I have two activities whose immediate predecessor is C, activity D and activity E. So I want to show that on my project network. So what I'm going to do, I'm going to grab, see how if I come over here to the corner circle, my cursor changes to those two arrows. It allows me to move it to the way I want it. So I'm going to move that there. And I'm going to say, okay, coming off of C, I can do both D and E. So I can have two things coming off of here. So I'm going to have C and D. So I'm going to grab one of my blank nodes. And I'll put activity D over here. And activity E over here. So again, coming off of the immediate predecessor of activity C, I can D, put up the roof, and E, install the exterior plumbing. So activity D is my roof, and the roof duration takes 6 weeks. Okay, and then I have activity E, which is exterior plumbing, and the duration of exterior plumbing is 4 weeks. Okay. So we're down through E. Now, we have to be careful now what can happen next. F, its immediate predecessor is E. So I can come off of activity E and do activity F. So let's copy one of our nodes over here. And that's going to come off of activity E. I want to draw my arrow, so Control C, Control V, make it a lot shorter, and then let's move it over here. And this is activity F, which is the interior plumbing, and activity F takes 5 weeks. Okay. Activity G, its immediate predecessor is D, exterior siding. So this activity G has to come off of its predecessor D. So that's over here. So let's get another blank node. and show that this one needs to come off of activity D. So this is activity G, exterior siding. Exterior siding takes 7 weeks. Okay, H. Now notice here, to do activity H, exterior painting, I have to have completed both E and G. So H has two immediate predecessors, G and E. So I'm going to grab another blank node, put it on my sheet. This is activity H, which is exterior paint. Exterior painting takes 9 weeks, but it has two immediate predecessors. Both E, the exterior plumbing, and the exterior siding have to be done before we can do the exterior paint. So what I'm going to do, I just realized I didn't put a line for my D to G. Let me do that. Control-C, Control-V. Probably a lot of you saw that, like, why doesn't she have a line there? I did miss that. Okay, so both G and E have to happen before H can happen. So I'm going to show G coming down here. Struggling with my arrow. And then also E. So I'm going to grab this one because that looks like an arrow I can use. And I'm going to show that E is an immediate predecessor to H. So notice I have two things that have to be completed before I can start exterior painting. Okay? Alright, so we've done H, now we're up to I. The immediate predecessor to I is all the way up at C, do the electrical work. Alright, so I can do another, just going to grab this one because it's closer. I'm going to do another node coming off of C, and this is going to be I, the electrical work. And the electrical work, I, takes 7 weeks. And then I'm going to show that that can also come off of activity C. So notice activity C can, once we rough out the wall, several different activities can begin. Alright, so we've done I. Let's go back over. Now we're up to J. Put up the wallboard. Activity J cannot start until F, which is the interior plumbing, and I, which is the electrical work, begins. Or ends, excuse me. So F and I have to be done before we can begin on J. So again, I'm just going to copy one of these because it's closer. Put it here. And this is activity J, which is the wallboard. And activity J takes 8 weeks. And we want to show that that cannot begin until F and I are done. So I want to grab a couple of arrows and show that it has to come from F has to be done, and then I has to be done. So I'm showing that J cannot begin until these two activities are done. Alright, let's see about K. K, install the flooring. Its immediate predecessor is J. So I'm going to come back over here. The immediate predecessor for J, for K is J. So I'm going to copy this one. This is going to be K, which is the flooring. And the flooring takes 4 weeks. And J has to be done before K can be done. Okay. Then we have L, do the interior painting. Its predecessor is also J. So J is the predecessor to K and L. So I'm going to copy again. This is going to be L, which is paint. Oh, it's interior paint. I want to be specific here. So interior paint. And interior paint takes 5 weeks. And it can begin once J has finished. So I'll copy that arrow. Okay. M, install exterior fixtures, can begin once A, its immediate predecessor, is done. Let's go over here and find H. Here's H. So after H, we can do M. I'm going to copy this. Okay, and this is going to be M, which is exterior fixtures, and M takes 2 weeks. And I want to draw my arrow, my arc. Almost there. Last activity, install interior fixtures, can begin once both K and L are done. So I'm going to come over here. Here's K and L. These both have to be done before I can do N. So I'm going to again just copy one that's close by. And this is N, which is interior fixtures, and that activity takes 6 weeks. And that's reliant upon its immediate predecessors of both K and L being done. That's the end of my project. So I have to show that it finishes. I have to have essentially another node. So I'm going to copy this again. And I'll just put it over here. And this is going to be my finish. It doesn't have a duration. It's the end. And both M will go to the finish and end, because those are the last in my project networking. So I'm just going to copy a couple of arrows here. So once I finish the exterior fixtures down this project map, that'll be done. And then once I finish the interior fixtures, I will be done. Okay, so a lot of work, as you can see, but this is our project network, okay, where we have all of our different nodes, our activities, and then our arcs or our arrows showing what are the immediate predecessors that have to be completed before we can begin the next activity. So I would recommend, if you were struggling to maybe keep up building your project network, stop the video, take your time, get all of this in place before we move on to the next section, which is determining our critical path, and then filling in these blanks. What is EST, LST, EFT, LFT? So make sure you have this all done before you move on. What we're going to do next is we're going to identify what is the critical path in this project network that I just built. So the path is following those arrows through the network, through any one of the routes that takes us from the start to the finish. The length of the path is the sum of all of our estimated durations of the activities on the path. So if you look at what we have over here, remember these numbers were our durations. So a path would be following all of these different routes that get us to the finish. Okay, so there's several different paths through the project. The estimated project duration is equal to the length of the longest path. That longest path is called the critical path. You may sometimes hear it as the long pole in the tent. Which path takes the longest to complete? A good analogy would be, let's say I have a friend who just did the Ragnar race that's made up of teams, and they were trying to estimate how long it would take them to complete the race. The race is going to take them as long as the slowest person in the race. And trust me, that would be me if I was in a race. But if it's a team finish, the team cannot be done until that last person crosses the finish line. So again, the long pole in the tent. If you look at how we built our node notation and the fact that we said in that center square in the bottom row, that was our activity duration, we can go through each one of the paths that we built and add up all of those durations. If we do that, what you'll see is the long pole in the tent, or the critical path, is the path that takes us from A to B to C to E to F to J to L, and that equals 44 weeks. So the soonest we could complete this project would be 44 weeks, because this path is our longest path. So over here, A to B to C to E, can't remember which, I've got to go back through my notes, I don't remember offhand, to F, to J, to L, to N is our longest path. So that's actually our critical path. And what you can do, you can change, if you wanted to, the color of your lines to red to show that that's our critical path. You could draw that through your project. So each one of these is my critical path. So that's my critical path through this project. It is the path that takes the longest to complete, because the project's not done until the last item is done. Okay, so that's one way that we can figure out our critical path, our longest pole in the tent. Another way that we can look at it is looking at what we call earliest start time, earliest finish time, latest start time, latest finish time. So you can see here are those abbreviations that we're using in our Excel worksheet. And what this is going to allow us to do is identify those activities on the critical path that have to stay on schedule, or they will affect the completion of other activities. So let's define these. When we're looking at earliest start time and earliest finish times, we can also view that as a forward pass, meaning the activity that is the predecessor can't start until the other predecessor finishes. Okay, so the rule for calculating the earliest start time is to take the largest earliest finish time of the immediate predecessor. And again, this might be a little confusing when we're just reading through the words, but we're going to go back to our Excel and it'll start to make a whole lot more sense, because you'll be able to build a formula that makes sense. The procedure for obtaining the earliest times for all activities, so both our earliest start and our earliest finish, is for each activity that starts the project, remember we had our start node, its earliest start time is 0. That's the start of our project. For each activity whose earliest start time has just been obtained, we're going to calculate the earliest finish time, which is its start time plus the duration of that activity. That's the earliest it can finish. For every activity who comes off of that predecessor, we now have the earliest finish time from that predecessor. So to obtain its earliest start time, we're going to use what's known as the earliest start time rule, and that's the latest finish time of the immediate predecessors. If it only has one predecessor, then its earliest start time would be the predecessor's earliest finish time. But remember, in ours, we had a couple of scenarios that we had to wait for two things to be done before we could start the next activity. So we would look at, well, what's the latest finish time of those two immediate predecessors? And then we repeat the activities. So I'm going to work through that first, and then we'll come back and we'll talk about latest start time, latest finish time. So let's go back over to our Excel document. And here we have our diagrams. Okay, remember that the start time, the earliest start time is 0, and the earliest finish time is 0, because that's when we start the project. Okay, so that means excavating the earliest start time is at week 0. Okay, now remember, the rule to calculate earliest finish time is the start time, the earliest start time, plus the duration of that activity. So I'm going to use a calculation. Equals the earliest start time plus the duration of that activity. That's the earliest that excavation can finish, 2 weeks. Now, my earliest start time for my next activity is the earliest finish time from the previous activity, which was week 2. So the earliest the foundation could start would be, I'm going to point to it actually, the earliest finish time of the immediate predecessor. The earliest we could finish our foundation would be week 2 when we start, plus the duration of building the foundation. So my earliest finish time is equal to earliest start time plus duration of that activity. Okay, the next successor is activity C. So the earliest activity C can start would be the earliest that activity be finished. That's its only predecessor. So that's equal to week 6. Can't start roughing the wall until week 6. The earliest that we could finish roughing the wall would be the earliest that we can start plus its duration. So its earliest finish time would be equal to earliest start time plus duration of that activity. Okay, take a minute to make sure you're understanding the logic of those, because those ones were fairly simple because it just had one immediate predecessor. Okay? All right, now let's go down through this path for a little while. We'll eventually have to work all of them because when we get down here to H, we can't figure it out until we know both of them. So let's go to D. So the earliest activity D can start would be the earliest that activity C, its immediate predecessor, finished. So week 16. The earliest that it can finish is the start plus the duration. So earliest finish time, earliest start, plus duration of the activity. Let's do them in alpha order. E, its earliest start time is coming off of its predecessor. C ended, earliest it can end is week 16. So that's the earliest that E can start. The earliest that E can finish is the 16 weeks plus the 4 weeks of duration for that activity. You can hopefully see why this is called the forward path method, because it's dependent upon what happened behind it. So it's like passing the baton to the next activity. All right. So I said I was going to go in alpha order. Let's go to F. So F's the only immediate predecessor it has at this point is E. So its earliest start time would be equal to the earliest finish time of E. The earliest start time plus its duration would be the earliest that F could finish. So earliest start plus duration is the earliest that F can finish. All right, let's go to G. The only predecessor to G is D. So its earliest start time is equal to the earliest finish time of its predecessor, D. Its earliest finish time is the 22 plus the 7. So start time plus duration. Okay, now notice we're going to H, but H has 2 predecessors. The earliest that G finishes is week 29. The earliest that E finishes is week 20. Remember the rule. We're going to take the latest finish time of the immediate predecessors. So the latest between the predecessor of G and E is 29 weeks. So that's the earliest that exterior paint or activity H can start, because activity H is dependent on both G and E being done. The earliest G finishes is week 29. The earliest E finishes is week 20. So we take the latest. So the earliest that H can start is the latest EFT of the immediate predecessors. And then it can finish, the earliest H can finish would be equal to the EFT plus the duration. Okay, so H. Now let's go over to I. So we're going in alpha order here. Okay, the immediate predecessor to I is activity C. So its earliest start time is the earliest finish time for I. For activity C. Its earliest finish time is early start plus duration. Hopefully you're getting the pattern here, and you're probably at this point working ahead of me saying, hurry up already, we're moving on. But if not, slow it down and take your time, okay? All right, so I have H, I, now we're on to J. Okay, now we have to take a look because J has 2 predecessors. Remember, the earliest it can start is the latest its predecessor finishes. So we have F has to be done, and the earliest F finishes is in week 25. I has to be done, and the earliest I finishes is week 23. So the earliest that we can start activity J would be week 25, because it's dependent on both F and I before it can start. Its earliest finish time then is equal to earliest start time plus duration. All right, then K just has the one predecessor, J, so its earliest start time would be equal to the earliest finish time of J. And then its earliest finish time is equal to start time plus duration. All right. L. L has two predecessors. So again, we have to look at what's the earliest finish time of its two predecessors. Okay? So the earliest that L can start, oh, I take that back, sorry. L does not have two predecessors. I'm sorry, guys. I'm sorry for the confusion there. L only has one predecessor. It's coming off of J. J is a predecessor to K and L. But L only is dependent upon J being done. So the earliest that L can start is the earliest that J finishes. So equals the earliest finish time for J. And then its finish time is equal to start plus duration. Sorry for the confusion there. L just has one predecessor, which is J. All right, let's go over to M, following my alpha theory here. Okay, M only has one predecessor, which is H. H, earliest finish time is 38. So that becomes L's earliest start time. Or excuse me, M's earliest start time. Too many alpha characters. Its earliest finish time is the 38 plus the 2. Okay, N. N has two predecessors. K finishes in week 37. L finishes in week 38. So that's the earliest that N can start, because it's the latest of its predecessors. So then the earliest it can finish would be week 44. So now if I go to my finish, the earliest that it can finish is the latest. So essentially the earliest start and the earliest finish are exactly the same, because there's no activity duration associated with the finish. So you can see that the earliest we can finish this project is 44 weeks. Again, that working with the earliest start and earliest finish is known as the forward pass. Again, I recommend stop the video for a couple minutes, make sure you're understanding how we did those calculations, and then come back and let's talk about the latest start and the latest finish. The latest start and the latest finish are what's known as the backward pass. So we actually start from the finish and work our way up to the start. Okay, so we start with our latest start time and our latest finish times. Okay, the rule is the latest finish time is equal to the smallest latest start time of the immediate successor. So now in looking back, in the earliest start time we look backwards, okay, what happened before it, and then I calculate coming forward. Now I'm going to look backwards and calculate going backwards. Okay, backward pass. Again, lots of words, but hopefully it's clearer when we actually work it on the Excel side. The procedure for obtaining the latest time for all activities is we start at the completion of the project in our finish mode, and our latest finish time is equal to the earliest finish time. For each activity whose latest finish time has just been obtained, we calculate the latest start time, meaning how late can I delay the start of this activity by using the latest finish time minus the duration of that activity. For each new activity whose immediate successor, now remember that's the one in front of, not behind, that we now have a latest start time value, we obtain that latest finish time by applying this latest finish time rule. So that's that activity's latest finish time is the smallest latest start time of its immediate successor. So again, a lot easier if we just look at it over on our Excel side. So let's go back over there. Okay, remember, we're doing backward pass. Okay, so we're starting at the finish and going backwards up to our start. All right, so remember, latest start time, latest finish time is equal to earliest start time, earliest finish time. So I'm just going to put those in. Those should all be the same number of weeks. Okay, so now let's go backwards and we'll start with N. So if you remember the rule, we just filled in our latest finish time, okay? We calculate the latest start time for N as that latest finish time of its successor minus the duration of N. So the latest finish time for N is equal to the latest start time for its immediate successor, which was the 44 weeks. But to figure out how late can activity N start and still meet our 44-week finish time, that's going to be equal to latest finish time minus the duration of that activity. So activity N has to start in week 38 in order to meet our finish time. Okay, let's look at M. Again, the latest finish time is equal to what we have over here. But now we're going to look at, okay, so in order, if activity N has to be done by week 44, what's the latest it can start? Equal to latest finish minus duration. So what you can see here by this methodology, that says that activity N can be delayed. It doesn't necessarily have to start until week 42 to meet our 44-week deadline. The earliest it can start is week 38, but if we don't get to it until week 40 or 41, it's still not going to affect my finish time. Okay, so long as I start by week 42. Okay, let's go over here to L. My latest finish time for L is my latest start time for its immediate successor. So activity N has to start by week 38. That means activity L has to finish by then. The latest it can start is equal to the latest it can finish minus its duration. Same thing here. Activity K has to be finished by week 38. So that can so activity N can start. The latest it can start so that it is finished by week 38 is equal to latest start time minus duration. So once again, you can see that if I don't start putting down flooring till week 34, I can still meet my project deadline because it'll take me 4 weeks. So I have a little bit of wiggle room in there. Slack. Okay, let's go to J. For J, we're going to pick up the latest, let me say this correctly, the earliest latest start time, A little confusing there. But you can see, because J leads to both K and L, L has to start by week 33. K has to start by week 34. That means J's got to be done by week 33, because that's the start time, the latest start time for the next successor. Okay? So that has to start there. The latest J can start is its finish time minus its duration. Again, I'm going to look at where does the two successors to J are K and L. Well, L needs to start. The latest it can start is 33. That means that's the latest that its predecessor can finish. All right. Let's go to H. This one only has the one successor, so the latest that it can finish is going to be equal to the latest it can start, its next successor. So that's equal to the latest start time for M. Its latest start time then is equal to latest finish minus duration. So again, you can see exterior paint can push all the way out to week 33 and still be on schedule. All right. Oh, I skipped I. Sorry about that. Okay. I only has one successor. So its latest start time is 25. So I has to be finished by week 25. Therefore, the latest it can start time minus duration. So again, I can start a little bit later and still keep the project on schedule. Let's come over here to interior plumbing. The only successor, the activity done after plumbing on this path, is the wallboard. The wallboard has to start by week 25. That means that's the latest that plumbing can finish. The latest that plumbing can start is the latest it can finish minus its duration. So you're starting to see a pattern here. See, there's no wiggle room here. It has to, earliest it can start is 20. The latest it can start is 20. Notice that that's starting to equal. You see the pattern here? There's no wiggle room. That's our critical path. If something gets delayed, it's going to delay the next activity. All right, let's do exterior plumbing. Exterior plumbing has two successors. It has to finish in time for the latest, the earliest the next project can start. Okay? So in this case, the successors to plumbing are interior plumbing and exterior paint. The latest that exterior paint can start is week 33. Okay? But the latest that interior plumbing can start is week 20. So that has to be the latest that activity E can start, because it is the smaller of these later start times. The latest start time for exterior plumbing is finish minus duration. Again, notice that pattern? It's on my critical path. All right, exterior siding. Its only successor to exterior siding is exterior paint. And the latest start time for exterior paint is week 33. So that's the latest finish for exterior siding. Latest start time for siding is finish time minus duration. Again, notice we have some wiggle room, some slack in when our siding can start and still keep our project on track. Okay, looks like The next one is my roof. Its only predecessor, or excuse me, successor is siding. So it has to finish by week 26. And therefore it has to, the latest it can start is week 20. Again, we have some wiggle room in our roof. Okay, now let's look at roughing the wall. It has 3 successors. There's arrows going out to 3 different activities. The latest the roof can begin is week 20. The latest the exterior plumbing can begin is week 16. And the latest the electrical can begin is week 18. Roughing the wall has to be done by the earliest of the, or the smallest of the latest start times. So that's 16. So the latest roughing the wall can finish is the latest, the smallest of the latest start times for its successors. So the latest it can start is finish minus duration. Again, notice critical path. Okay, the foundation only has 1 successor, so the latest it can finish is week 6, and the latest it can start. And then we back up to activity A. The latest it can finish is week 2, and obviously this should then be 0. If we're going to stay on schedule, it has to start at our designated start time. So again, that's known as the backward pass when we're figuring out our latest start time and latest finish time. Again, I recommend stop the video, work through how we got all of these numbers, because they'll become important when we move on to the next concept, which is calculating the slack time. Okay, so let's talk about how we calculate the slack time and the critical path. You should have already seen that visually as we were working through that Excel file, trying to calculate latest start time, latest finish time. You saw that what we had identified as a critical path, there wasn't any slack or wiggle room. Okay, slack is the length of time an activity can be delayed without delaying the project. How we're going to calculate that slack is take our latest start time minus our earliest start time. Or we could do it the other way, latest finish time minus earliest finish time. The activities that have 0 slack are critical activities, meaning if they don't start when they're supposed to start, then it will affect every activity after that. The critical path, as we have already identified, is that continuous path through the network that shows us from start to finish those critical activities that have no slack. Okay? There's 2 different types of slack. We can have slack time that is shared by more than one activity. So we might have 2 weeks worth of slack time, but it's for all of the activities in that path. Or we can have free slack that's associated only with that one activity, where it's not rely upon anything else. Again, it's easiest if we go over to Excel and show that numerically. So back to our Excel file, and what you'll notice is I have a second tab, and this second tab, slack time, is the same project we're working on. But what I did to save us some time was I went and put in all of the numbers that we calculated over here. So if you want to take a minute and convince yourself that it's the same numbers, it is earliest slack time, or excuse me, earliest start time, earliest finish time, late start time, latest finish time for each one of the activities that we calculated. And I was just saving us a little bit of time. How we calculate slack is to take our latest start time minus our earliest start time. Again, make Excel do the work for you. I should only have to do this formula once, and then I can copy it down. So equals latest start time minus earliest start time. Okay, if you do that, I'm not holding anything constant. For activity A, latest start time is week 0, earliest start time is week 0. Okay, enter. what I can do then is just copy this down, and it'll calculate the slack time for every activity. Save me a whole bunch of time. Don't have to rebuild that formula. And it's always a good idea just to randomly check to make sure something didn't go wrong in your formula, but everything looks good. It's doing exactly what we wanted it to do. Now remember, an activity is considered to be on the critical path if it has 0 slack time, meaning it has to start when we have scheduled it. Okay? So, on the critical path when there is 0 slack time in that activity. So, activity A is on the critical path, B and C. D has some slack time, meaning that I have some wiggle room. So no, that's not on my critical path. E is on my critical path. F is on my critical path. G is not. H is not. I is not. J is. K is not. L is. M is not. And N is. So if I start to look at, highlight these a different color, what we said by using slack time, what was on the critical path, what you're going to see, I just want to highlight all of these. So if I look at this, it's A to B to C to E to F to J to L to N. Right? That's everything that I said was on the critical path. Go back over to this slide. That's what we said here. A to B to C to E to F to J to L to N to finish. That's on our critical path. Okay? That's exactly what we have identified here through the slack time. There's no wiggle room. If something gets delayed in any one of these activities, our project will be delayed. Okay? Okay, so that's the critical path method. What you will find if you go over to Canvas is I have a file with some practice problems for you. I realize that the homework isn't available in Connect, so these are actually problems at the end of the chapter that you can practice. So I've got 5 different problems that you can practice, and then the solutions are there for you to be able to check your work. You do not have to do all the problems to practice. You will not be turning this into me. This is a way for you to build your confidence in working the problems. Once you feel confident in how to use this critical path method, how to calculate the earliest and latest start times and the activities, then what you will do is go over to Canvas and you will find in the assignments the homework file. The homework file has 2 tabs. There's 4 questions on the first tab, and then question 5 is actually you building the whole project network, identifying the critical path, earliest and late start times, and the slack activity. Okay, so the homework is mandatory. You would work this file, save it, and then go ahead and submit it through Canvas assignments. Again, if you have any questions this week, please feel free to reach out to me. I am here to answer any questions you may be having with this material. Have a great week, everyone.